Welcome back. Now we are going to talk about repeated games. What do we mean by a repeated game? A typical strategic interaction that we had discussed earlier, it was assumed that different decision makers called player, they interact once and only once. Here we are going to extend what happens if the players interact again and again. Okay, and of course this interaction has to be a strategic setting. For example, we have talked about prisoner's dilemma, Ranga and Billa, that they are trying to rob a bank or they got caught, and then whether they confess or do not confess, it constituted a strategic interaction. What happens that if they go to jail or if they don't go to jail and again they interact in the next setting, next year they try to rob another jail, this kind of questions that we have in mind. So what happens when players interact again and again in interactive session, in a strategic setting? Can cooperation be sustained? So as we have seen in the prisoner's dilemma, the both players would like to confess. It means they defected, they didn't cooperate with one another. So the question is, can cooperation be sustained between two or more players interacting strategically in, let us say, prisoner's dilemma like situation? Of course, we are going to talk about mostly prisoner's dilemma like situation, but the notion, the concept can be extended to other games also. Can reputation or punishment play any role in such a strategic setting? Because if you are known that you cooperate, you are a nice person, you help each other, perhaps that can help you increase the payoff. Or sometime you can threaten the person that if you don't do this, I will do something else in the next period and that will harm you more. So that kind of punishment. So the question is, can reputation or punishment play any role in repeated strategic setting? Sometime we exhibit in real life tit for tat. Okay, he didn't behave with me properly, I should also do similar thing to him. This is what we call tit for tat in day-to-day language. We will see whether it is a good strategy or not, particularly in context of prisoner's dilemma game like setting. So in a repeated game, we can say a game, let us call it G, what happens that G is played multiple times. So we define that we say that one time playing of G is called stage game. This is a single play of the game. And each occurrence of G is a game that we are playing, is called an iteration or a round. Okay, so keep in mind that if we have prisoner's dilemma, let us say 2, 2, let us say AB, AB, and here is 3, 0, 0, 3, 1, 1. This is a prisoner's dilemma kind of setting, and this is getting repeated again and again. It means player 1 and player 2 are coming together and interacting again and again, and deliberately I have taken out Ranga and Billa kind of story from here, because once they are in a jail for 20 years, it would not be possible to interact again. So let us say they are interacting and they are getting the payoff of at max 2 or 3, something like that, and then they can interact again. So this is one stage, and this is getting repeated again and again. So in one round this is being played, and then again the same game is being played. The example is of course a repetition of prisoner's dilemma. So we can talk about two different kind of repetition. One is finitely repeated. It means finite means a number that can be counted 100 times, 200 times, 1000 times, and so on. And second is infinitely repeated games, when we cannot keep count of the number of time this game gets repeated. Okay, so in finitely repeated, we have finite and known number of repetition, and in infinitely repeated game, the game continues forever. there is another possibility, that game that ends at a random unknown time. So there is a possibility that two players interact once, and then there is a probability p which is positive that they will again interact, and always there exists a probability p greater than 0 that they will interact in the next period. Such games can also be modeled as infinitely repeated games. Of course, for such situation we have to make certain assumption. The assumption is that players observe and remember the outcome of all previous stage games. This is very, very important. Okay, they do not forget what happens in the earlier stage. They very well remember what has happened in earlier stage. And players could have a different response for each observation of the outcome of a stage game. So it is very much possible that in first 5 stage they cooperate, and later 5 stage they don't cooperate. At least there exists such theoretical possibility. In other words, we are talking about the extensive form game in which players can change, modify their action in the middle of the game. We are not talking about the normal form game where players decide once and for all. So now let us look at a prisoner's dilemma kind of a setting. Here we are talking about here two strategies I have written: cooperate and defect. Cooperate is equivalent to earlier remaining silent, because that would help one, they in that way they would help one another. And defect is equivalent to confess. It means cheating with the other, because if one person cooperate and other person defect, other person confesses, he gets higher payoff. If you obtain the Nash equilibrium, let us quickly obtain the Nash equilibrium. What do we see? That defect is a strictly dominant strategy for both the player. Why? Here 3 is greater than 2, here 1 is greater than 0. For the other player, you see here 2, you can compare with the second number. 3 is greater than 2, because for second player we have to look at the second number. Here is 0 versus 1. So both players defect is strictly dominant strategy. It means defect comma defect is strictly dominant strategy equilibrium, and we have already studied that strictly dominant strategy equilibrium is necessarily a Nash equilibrium. Remember, not all Nash equilibrium are necessarily strictly dominant strategy equilibrium, but all strictly dominant strategy equilibrium is Nash equilibrium. We can check also quickly. Let us check that. Let us get rid of these pen marks, and we can check. Player 1 in thinking that player 2 is going to cooperate. Cooperate gives 2, defect gives 3. So defect is better. Player 1 thinks that player 2 is going to defect. Here cooperate gives 0 to player 1, defect give 1 to player 1. So defect is higher. So here are the marks. Best responses have been marked for player 1 in blue color. Now we can do in purple color best responses for player 2. If player 2 thinks that first one is going to cooperate, defect is better, because defect will give player 2 3 and cooperate will give only 2. And similarly, if player 2 thinks that player 1 is going to defect, again defecting is better, because defect gives 1 and this is only 0. So this is the best response. So here we see in this box D defect comma defect, in short D comma D is a Nash equilibrium. D comma D is any. So that we have obtained many times. So there is only one pure strategies. Now the point is that this game is repeated. This strategic interaction is repeated t times. T is a finite number, means t is equal to 2, t is equal to 5, t can be 1000 also, doesn't matter. How should we write the payoff? Are there any strategies possible that would sustain C comma C as an equilibrium strategy in at least one of the rounds? So of course we see here D comma D happens only if one time it's repeated, but the important point is that is there any strategy such that what we get as outcome in one of the stages is here C comma C in place of D comma D. So this is what we have to obtain. So simply we will take first T is equal to 2. So we are going to repeat this game only twice. Before the second stage game, each knows the outcome of the first stage game. So what happens in the first stage game, they will come to know. What is the assumption? We will say the payoff is the sum of earnings on the two stages. Now how we are going to solve it? The idea is just that to use extensive form game. So we can do this. Let's say that player 1 can cooperate, can defect. Player 2 doesn't get to observe, and then player 2 can cooperate or defect, cooperate or defect. If both of them cooperate, then the payoff comes out to be 2 comma 2. If first one cooperates, second one defects, the payoff was 0 comma 3, here 3 comma 0, and here it is 1 comma 1. What we are going to do, we will say that although they know the payoff, but we will keep it hidden. We will not necessarily write it. What we will say that now let us say the second stage of game is played, and here you need to pay attention. That there are 4 different possibilities, at least theoretically speaking, that a game starts after first player has played C and second player has played C, and again the same thing is being played. And this is player 1, this is player 2, C, D, C, D, C, D. And that's also possible that same thing would happen here if player 1 has played C and player 2 has played D. Remember, what did we say? This whole strategic interaction has 2 stages. It means the game, the prisoner's dilemma game, gets repeated twice. So twice they have to interact. It doesn't matter what they have done in the first round, they are again going to interact. Okay. So here again player 1 decides C, D, C, D, C, D. Similarly, we can do like this just to save space. C, D. This is player 1, this is player 2, C, D, C, D. And here also C, D, player 1, player 2, C, D, C, D. So before we proceed, we should also revise what we have been doing. If we pay attention to how many subgames do we have in this game? My take is that in this game there are total 5 subgames. How 5 subgames? One is starting here. Second starting here after player 1 has played CC. Third is starting when player 1 and 2 have played CD. Fourth is starting here, and fifth is starting here. Note, subgame cannot start here because 2 is not able to figure out that at which node it has to act. Similarly, player 2 cannot figure out here. Player 2 cannot figure out here. So there are 5 subgames. Out of 5, 1 is the whole game, the complete interaction. We can say the complete interaction, and 4 are in the second stage. Can we call the first stage game as a subgame? No, because in the first stage, strategic interaction is not ending. There is a complete strategic interaction that begins at initial node and it proceeds for 2 periods. So whole game is a subgame of itself. But here a subgame at these 4 points, here, the 4 subgames are starting. Which one is going to happen is immaterial. Right now we are drawing the possibility. So if you think of the second stage subgame, what is going to happen? The payoffs are very simply can be written as, because of CC is going to be 2, 2 and CD is going to be 0, 3, 3, 0 and 1 1. But the problem is this is the payoff in the second stage only. What is going to happen in the first stage? First stage here they have played CC. It means their payoff from the first stage is 2 comma 2. So if we are simply adding them up, so we can add them up here, 2 comma 2, 2 comma 2 plus 2 comma 2 plus 2 comma 2. So what are we going to get? We are going to get 4 comma 4 here, 2 comma 5 here, 5 comma 2 here, and 3 comma 3 here. Similarly, I'm not going to do for all cases. I recommend that you do it for all cases. Here I can write in the second stage C comma C, they get 2 comma 2, this is 0 comma 3, this is 3 comma 0, and this is 1 comma 1. But this is happening after D comma D. So in D comma D, in the first stage, they are going to obtain, and we can check once, they are going to obtain in D comma D 1 comma 1. So earlier we had added 2 comma 2 here in all 4 branches. Here we should be adding 1 comma 1 because first stage would give them 1 comma 1. So this is going to be 3 comma 3, 1 comma 4, 4 comma 1, and 2 comma 2. So this is the way we can complete the process here also. So if you pay attention, basically what is going to happen in the second stage? Let us say that we take one of the second stage as simply we take this second stage. What is going to happen in this stage? So this is basically one of the subgames, one of the 4 subgames that's happening at the second stage, and this I can write it simply. I can write it here. Player 1 decides to play C or D. Player 2 doesn't get to observe, can play C or D, C or D, and the payoffs here are 3 comma 3, 1 comma 4, 4 comma 1, and 2 comma 2. This can be written in the normal form as C D, C D, 3 comma 3, 1 comma 4, 4 comma 1, and 2 comma 2. And let us see what happens here. We will check for player 1 and player 2. What is happening? If player 1 thinks that player 2 is going to play C in the second stage, anyway the game is ending in the second stage, what player 1 should do? That D is better because D gives 4 in comparison to 3. And if player 1 thinks that player 2 is going to play D, again D is better in comparison to C because C gives 1, D gives 2. And similarly we can check for the other player, that is player 2. If player 2 thinks 1 is going to play C, then D is better for player 2. Remember, we have to look at the second number. Second number is 4 here. 4 is greater than 3 and 2 is greater than 1. So this is the best response and they will end up playing D comma D. Now I am going to make a larger point because we can solve for all 4 individually. But let us look at how we are obtaining the numbers here. Numbers were earlier, to begin with, we began with a prisoner's dilemma in the second stage, and that number is 2 comma 2, 0 comma 3, 3 comma 0, and 1 comma 1, C D C D. But first stage, some decision is being taken, so that number has to be added. Let us say that number is A comma B. So here we are adding A comma B. Here also adding A comma B, here also adding A comma B, here also adding A comma B. This is what happening in this subgame, this is what is happening in this subgame, this is what is happening in this subgame, and this is what has happened in this subgame, for which we have done extensive calculation. So if, because A comma B, if we are, when we are thinking, now let us proceed further, when we are thinking from player 1's perspective, and player 1 is thinking that player 2 has played C, we have to compare now between 2 plus A and 3 plus A, because A is being added in both the numbers. So what matters is that 3 is greater than 2, and the best response will come here in D. And similarly, because 1 is greater than 0, so 0 plus A is going to be smaller than 1 plus A, so best response will come here. And similarly for player 2, because earlier we have figured out the best response is here, the best response is here. Let me use green, I am not supposed to use. So best response is here and the best response is here. So the stage nash equilibrium will come in the box D comma D. In also what we have figured out, that whether this subgame, people are going to play D comma D. Is it clear? Let me talk about it slightly differently. Let me again say quickly, the game is like this. One CD, two CD, CD, one CD, two CD, CD. So this is what we are getting. If you think about it, how many times player 1 has a play in this game? Player 1 has, because there are 5 subgames, we can say player 1 has a 5 plays. One at the beginning, then at this point, then at this point, then at this point, and then at this point. And at each node, player 1 has 2 actions. So in the beginning 2 action, in this subgame 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 2 action. So total player 1 has 32 different strategies possible. What could be name of some strategy? That always cooperate, means C, 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 C. Another could be always defect, which is D, 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 D. There is a possibility that cooperate in the beginning, cooperate in the first stage, defect in second stage. So how can we represent it? This C, D, 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 D. It's also possible that defect in the beginning and cooperate if player 2 has cooperated in the first stage, otherwise defect. This is a long way to describe. So we are describing, one of those 32 possibility. So how can we write it? First letter is for the first stage, so defect in the beginning, so D. The second letter is coming from when player 1 and 2 have played CC. So it means player 2 has cooperated. So in this case, player 1 will also cooperate. In the second game, how do we get second subgame here? Because player 2 has defected. So after that, player 1 will also defect. How do we get third subgame in the second stage? This can be named as 1, 2, 3, 4. How do we get third subgame? That player 1 has defected, but player 2 has cooperated. So here the strategy is that if player 2 has cooperated in the first stage, player 1 should cooperate in the second stage, C and D. So this is the way it can be written in the sort D, C, D, C, D. This is the way this can be described, the third strategy, but I am not going to describe all 32 of strategies. How many strategies player 2 has, we have done for player 1. Similarly, we can calculate for player 2. So player 2 has a play. Let us see how many places player 2 has a play. One here, another here, another here, another here, at 5 places. And each node, at each information set, player 2 has 2 actions available. So how many strategies player 2 has? 2 multiplied in here 2, then here 2, then here 2, and then at this point 2, and at this node, this information 2. So 32. So if we want to describe this normal form representation, we are going to come up with 32 by 32 matrix, which is really going to be handful. So it's a very difficult to describe. So we would avoid doing that. But now you should get the idea, the way game looks like, the way we are proceeding in this particular game. So what is more important to us is to obtain subgame perfect equilibrium, because we have seen Nash equilibrium gives us sometime outcomes which are not credible. So anyway, here it seems it's a lot easier to obtain subgame perfect equilibrium rather than Nash equilibrium. So that is what we are going to do. So here I have written the complete possibility. So what we are going to see, that in this particular subgame, D comma D is going to happen. So how much is the payoff in D comma D? We can write it here. It is 2 comma 2. This subgame can be replaced by 2 comma 2 through the backward induction method. We have learned it in the past. Now same thing here. What is going to happen in this particular subgame? Again, we have already discussed. You can check it for yourself, that in this subgame again we will have D comma D. For your satisfaction, we can draw it also and see, CD, what we have here is 4 comma 1, and here is 5 comma 2, and C comma D is 3 comma 3 and 6 comma 0. Player 1 and player 2. Clearly 6 is better than 5, so this is the best response. 4 is better than 3, so this is the best response. Similarly for player 2, this 3 is better than 2, so D is the best response. 1 is better than 0, so D is again. So here also we see the outcome is D comma D. So this subgame can be replaced by outcome 4 comma 1. Similarly we can do it here. This subgame again, here D comma D would be played. So this can be replaced by 1 comma 4, that is the outcome, and this subgame can be replaced by again D comma D. So here 3 comma 3 is the payoff. So we can write the whole game after doing the one stage of backward induction. In the first stage, this is for the second stage, we are writing in one of the subgame in the second stage. Here we are writing for the first stage. So after C comma C, the payoff is 3 comma 3. After C comma D, the payoff is 1 comma 4. Here player 1 is playing C, player 2 is playing D. So player 1 is playing C, player 2 is playing D, and that's how we get in this box. Payoff is 1 comma 4. Similarly, now we don't need to be that careful. Through symmetry also we know, but if you are careful, first player is playing D, second player is playing C. So second player is C, first player D. This is the box, and in this box number is 4 comma 1, and here first player is playing D, second player is playing D. So this box, and the payoffs are 2 comma 2. So let us solve it. What happens? Again you will see that D is a strictly dominant strategy for player 1, and we will see that D is also a strictly dominant strategy for player 2. So in the first stage also they are going to play D comma D. In fact, if you pay attention, how did we get this number? What is one stage game that we are getting? If I write it 2 comma 2, here is 0 comma 3, 3 comma 0, 1 comma 1. In each of the box, if you add 2 comma 2, in the first box you add 2 comma 2, So 1 comma 1, because you know second stage in all the stages D comma D is happening. My mistake, D comma D is happening. So D comma D is 1 comma 1. So in the first stage 2 comma 2 plus 1 comma 1, this is 3 comma 3. This is what you get. After CD, this is 0 comma 3. Again add 1 comma 1, which is 1 comma 4. This box is happening. Similarly 3 comma 0, add 1 comma 1, you will get 4 comma 1. And in 1 comma 1 you will get 1 comma 1, you will get 2 comma 2. So you are in this box. So what did we get? That it doesn't matter if the game is repeated twice, players are always going to defect in this particular setting. In first stage they will defect, in the second stage they will defect. Let me now argue slightly in a different manner. Why do they defect in the second stage? Because in the second stage there is no future. They know, we have already decided that t is equal to 2. After period 2, the game is going to end. The strategic interaction has no future. So they are for themselves, and in the second stage they are going to, whether it's happening after C comma C or C comma D or D comma C or D comma D, in all four possibility, they are playing the same stage game. And in the same stage game, the only nash stage outcome is D comma D. So in the second stage they are going to defect. It's like earlier game, you know, whole thing that we discussed, that can shadow of future affect my today's behavior. But when in the second period interaction is going to end, there is no future. So they are going to play D comma D. They both will defect. In first period, people interacting, the strategic player interacting, they would see that in the next period they are going to defect. And so when they add up, the game strategic interaction remains the same, and in the first stage also they end up defecting. So this is what happens in such interaction. Now the question is, instead of 2 times, if prisoner's dilemma is repeated 1000 times, what is going to happen? How many subgames we will have? Really high number. It's difficult to calculate. In the first stage there is one stage game. In the second stage there are 4, and from each 4 they will have 4 again. So in the third stage you will have 4 to the power 2, fourth stage you will have 4 to the power 3, and in the last stage you will have 4 to the power 999. Really high number of different possibility. But don't allow this to bother you, that these are the different possibility. Ultimately they are going to repeat the same game in the 1000th stage. You know, that stage game remains the earlier prisoner's dilemma game. They will end up playing this game only, and doesn't matter, in all 4 to the power 999 different possibility, they will end up defecting. There is no other option, because this is the basic structure of the game. There is no future after the 1000th round. They will end up defecting. Now in 999 round, now we said that in 1000th round everyone is going to defect. In 999 round, if you see what is going to happen, it's like twice repeated game. Today is one period and tomorrow is another period. We have just figured out that in such game they will always defect. In 997, same thing is going to happen. They figure out that every time they are going to defect. So if you keep on coming back to the first round, and here players will always defect in this prisoner dilemma kind of a setting. So the way we answer it, that shadow of future doesn't matter here in this prisoner's dilemma case. So whatever we have been discussing, it's mathematically nice, but it really doesn't give us any result. That future doesn't matter, reputation doesn't matter. You will have the same kind of behavior ever. We have to get out of this. The whole idea behind this repeated game, that we need to get out of it.